for 2-3, classifying and simplifying polynomial expressions. Learning targets are that you will be able to classify polynomial expressions. And then, more importantly for the geometry that we're going to be doing in the first geometry unit, be able to simplify polynomial expressions using addition, subtraction, and multiplication. Division will come later when we've learned how to factor. We haven't done that yet. A polynomial, those of you who have Greek or Latin roots already know in just what this word means.
Many numbers.
Many numbers. Many numbers or many expressions. Usually involving the same variable or variables. We can have polynomials that have more than one variable. For now, we're not dealing with that. We're dealing with ones that have one variable. But that variable could have different powers, different exponents. Okay? So many expressions, we would have different exponents. Because it wouldn't be many expressions if let's say I had 2x and 3x and 5x. That's not really many expressions. What is that? What is 2x, 3x, and 5x if I add them together? 2x, 3x, and 5x is 10x. Because I combine like terms. So this is many expressions, different exponents. Okay? Now in standard form, polynomials are usually listed from highest exponent to lowest. So on the left, you should have your variable and your highest exponent. And then it would add all the other terms that would have x's, counting down the exponents until you get down to what's called your constant, your number that stands alone without a variable. We're going to look at some examples of that in a second. Classifying your polynomials. You can classify them by exponent or by term. To classify them by exponent, if I just have something, what degree does that have? What degree does that have? What exponent does it have? 1. If it's a first degree polynomial, like x plus 2, you guys know how to graph this. You know how to write an equation for it if I gave you points. Why? Because it makes what? What graph would that make? If I had y equals x plus 2.
Linear.
A linear equation. It's a linear equation that would graph a line. So this is linear. Whereas if I had x squared plus 2, maybe there's even an x in there. If the highest degree is 2, if the degree is 1, it's linear. If the degree is 2, then it's called a quadratic. And they do graph parabolas, yes. And we'll be factoring those to solve them. If it's x cubed, the highest degree is 3, then it's called a cubic polynomial. Or if it was a function y equals x cubed, then it would be a cubic equation. X to the 4th is a quartic. Polynomial. So the 5th would be quintic and so on and so forth. We're not going to go much higher than those 3. So wow, I moved my arm and hit the screen here. All right, so the first one's linear, second one's quadratic, third one's cubic, fourth one's quartic. Like a quart with an IC on the end of it. By term, classifying them by term, how many terms do I have here? 1. When you have one term, it's called a monomial. Some of you might not walk or take the bus home, but might ride your bicycle home. So if it has 2 wheels or 2 terms, it's called a, well, 2 wheels is bicycle, 2 terms is a binomial.
Trinomial.
And some of you rode trikes. Some of you are still riding tricycles. So it is a trinomial. Now there are other ones higher than this, but for the most part in mathematics, we normally stick to these 3. Anything higher, so let's say this is, for n is greater than 3, n being the number of terms, things that are added together. We would just call it n-termed monomial. Not monomial, I'm sorry, polynomial. So what if it has 100 terms? What am I going to call it? 100-termed polynomial. If it has 90 terms, I'll call it a 90-termed polynomial. Have fun writing out that problem.
No, thank you.
All right, classifying each by exponent and by term. So I'm going to do by exponent in black and by term in blue. And hopefully you won't be black and blue by the time this is done. All right, this first one, is it in standard form or not? No, you have to really look carefully, because if it's not standard form and you just grab the first thing, you're going to be wrong. This should actually be x squared plus 3x if it were in standard form. Since it is squared, it has a degree of 2, I'm going to call this what?
Quadratic.
A quadratic. Since it has 2 terms, I'm going to call it a binomial. Letter B, the highest degree is 3, so it is a cubic polynomial or cubic expression. And there are 3 terms, so I would call it a trinomial. Be careful, I'm not calling it because of the exponent, I'm calling it because of the might help if I could spell nomial and talk. Calling it that because there are 3 terms. Letter C, what's the degree on letter C?
Linear.
1, so it is linear because of degree 1. Because there is only 1 term, it is a monomial. Please take a moment to try letters A, B, and C. If you did it right, you got cubic monomial for A, linear binomial for B, and cubic 4-termed polynomial for C. Simplifying polynomial expressions. We're going to be looking at 2 primary skills here, adding and subtracting, and at multiplication. Multiplication is down at the bottom. Okay? So when we do this, we have to be careful. Are we multiplying things, or are we combining like terms? Okay? The reason we need to be careful is, and this is where people get lost, there's a difference between x squared, you don't have to write it down, plus x squared versus x squared times x squared. Which one of these am I adding exponents for? Addition or multiplication? Multiplication. The rule is called the product property of exponents. Now I add these, I now have 4 factors of x squared. That is x to the 4th. Whereas here, it's always x squared, but now instead of having 1 of them here and 1 of them here, I have 2 of them. Here, all I'm doing is combining like terms. Here, I'm actually multiplying, which was what I would be doing if I were distributing a term into other terms, okay, or into a parenthesis. We'll see that in just a second. What happened to my pages?
I don't know.
Oh no.
What did you do? Did you delete
I know what I did. Here we go. Now, one thing that we have to be careful, and I don't know why, on some of your tests you guys did this. I had people who, even though they knew they were supposed to be using the segment addition postulate or the angle addition postulate, maybe I had 2x plus 1 here and x plus 10 here, and the whole thing was 20. On their quiz, even though they knew they're supposed to set up piece plus piece equals the whole thing, I can't tell you how many people said, well, the whole thing minus one of the pieces will equal the other piece. And their logic was correct, but their math was extremely wrong, starting with the equation that they set up. What's wrong with this equation? Yes?
They're not congruent to each other.
Well, they're not congruent to each other. If they were, I could set this expression equal to this one, and I wouldn't even worry about the 20. I could even cut the 20 in half and set them each equal to 10. But instead of saying this plus this equals 20, which is how we use the segment addition postulate, I said 20 minus 2x plus 1 equals x plus 10. What did they actually subtract from the 20? What's being subtracted from the 20? The 2x. Did they subtract the entire segment of 2x plus 1?
No.
No. If you're going to use subtraction, we emphasized this when we did the whole supplementary complementary, you have to put it in parentheses to subtract it. So their equation, which should have started out as addition anyhow, by making it subtraction, they got it wrong because they didn't subtract the whole term. So they, from the very beginning, their equation was wrong. So we need to be careful about that. So in that case, if we are subtracting expressions like we're going to be doing in letter B, and like some of you wanted to do to set up a problem, you need to change subtraction. Change subtraction to addition of the opposite. I'm not going to write all that down. I'm just going to write down how we're going to change it. What we're going to do is distribute the negative, and then all you have to do is focus on combining like terms. Distribute the negative and combine like terms. Now, even if you're really, really good at subtracting things, some of you, when we did elimination, said, Mr. Ritter, I can subtract the equations and I always get it right. That's very, very few people, even people who are good at math. We tend to make more mistakes when we're subtracting than if we just think about combining like terms, even though we're still doing subtraction when we're doing that in some cases. So it's better to distribute the negative and then just treat them all as combining like terms. So simplifying each polynomial expression, again, I'm looking here. Am I multiplying in letter A? Am I going to be multiplying those things together? No. I am adding two things together. If you want, you're welcome to line this up. The first one is in standard form. This one isn't. So if you want, you can move those. That's a positive 12x squared. Now don't move them by doing the opposite. It's not an equation. I'm just lining things up. And then I have a positive 6x, and I have a negative 2. You don't have to do it this way. You can just highlight the ones that go together or circle them, whatever. When I put these two together, I get 15x squared. Mr. S, I appreciate you not interrupting. This is minus 2x and plus 2. Any questions on that? Yes, Andrew.
How'd you get the 12x?
I just got it from over here. All I did was move those. I put them in order from highest exponent to least, and I kept the signs the way they were because it was addition. And then I'm just adding vertically, combining like terms vertically. You don't have to do that. Most people don't. Most people would just circle and say, hey, I got 3x squared and I got a positive 12x squared here. There's my 15x squared. You can do it that way if you want. You don't have to line them up. When you get to letter B, though, you need to be careful, not because it's letter B, but because we have what? Subtraction. So I'm going to take that negative and I'm going to distribute to every term in the quantity, in the parentheses, whatever's being subtracted. So this is a minus 3x and a negative 11x squared and a positive 2. At this point, you're welcome to rearrange things so that they are in standard form, but you don't have to. What you're going to put together, I'm going to put together my positive 4x squared and my negative 11x squared, because those are like terms. I'm going to put together my negative 3x and my positive x, because those are like terms. And then unfortunately, my 2 doesn't have anybody to partner up with, but it can still be part of my equation, or my expression. So I'm going to have 4 and negative 11 gives me negative 7x squared. I'm not doing anything with the exponents because we're not multiplying or dividing. We're just combining like terms. negative 3x and positive x is minus 2x. And then this plus 2 is sitting over here. Any questions on that? Please try this for letters C and D. Be careful though, what is the negative on in letter C? Just this set of parentheses. It's not on any other set of parentheses, just that one. Okay? Give those two problems a try. We'll need time to do D. Does anyone have an answer that they'd be willing to share for letter C? David.
I got negative 2x cubed plus x squared plus 2x minus 1.
1 second. Negative 2x cubed. Sorry, it went too fast for me.
Plus x squared
Uh-huh.
plus 2x
Okay.
minus 1.
Minus 1?
Yeah.
Okay. Raise your hand if you also got that answer. Okay. We're going to look at any other answers. Tyler.
So I got that,
Except.
except I added 7.
So this is plus 7 at the end for you?
Yeah.
So this is a plus 7. Okay. You have a different answer.
Plus 9.
I got it where it would be
Plus 9.
Oh yeah,
Okay. So,
Sorry, can I
so for some of us, putting them in standard form and lining them up is going to help us, or circling and sometimes I double underline stuff. I can't do it on here as well. Like I'll double underline the x squareds and single underline the x's and circle the cubes or whatever. Andrea, did you get something different?
No, I'm just wondering, does it matter what order you put it in?
It does. We always want to go from highest exponent down to lowest and then the constant. I'm going to walk through that because there were a lot of you who did not get that answer, and I want to make sure that we can all get the correct answer. In distributing this negative, the sign changes on all of these. This becomes negative 4x squared, negative x cubed, and positive 2. So I'm going to combine. The highest degree was x cubed. I've got a negative x cubed here and a negative x cubed here, giving us negative 2x cubed total. Here I have a positive 5x squared minus 4x squared is 1x squared plus 2x squared. No, that's an x. Huh. Never mind. It's just x squared, right? Is that right? Yeah. 5 minus 4 is 1. And then our x terms, there's no x term over on the left expression. In the middle expression, there's only one. It's the 2x. And then my last thing that I have to do is add the constants. I have negative 3 and positive 2, which is negative 1. Negative 1 and 10 gives me the positive 9. It may help for you to write them in standard form and line them up. But if you can get it right without it, then don't worry about doing that. All right, letter D. Does anyone have an answer for letter D?
I got negative 5x cubed minus 6x plus 3.
Negative 5x cubed plus 6x plus 3. Raise your hand if you all. Oh, minus 6x. Yeah. Raise your hand if you also got that answer. Many of you, but not everyone has their hand up. So let's take a look real quick. If you did, awesome. We're going to distribute this negative 2 first, giving us negative 2x minus 4x cubed plus x squared. And now I'm going to highlight the terms that we should be combining together. I'm going to start with my x cubes. I got 4 of them here, but I lost 4 of them here. So I'm down to no x cubes. But then I go to this middle term and I got negative 5 right there. So that's where the negative 5x cubed comes from. You can combine them in a different order. You're still going to get negative 5x cubed. Now I'm going to combine my x squareds. I have a negative x squared here, none in the middle terms, and then a positive x squared here, which means I don't have any x squareds to put in my final expression because they just cancel out. For my x's, I don't have any in the first expression. I have negative 4 of them here and negative 2 of them here, giving me negative 6x. And lastly, I have a positive 3 right here, and that's it. There's no other constants to combine it with. Questions on those? All right, so now we are looking at, I hope I was recording for that, yep. Now we're looking at multiplication, which you guys at this point, and girls, should be really good at multiplying things that have the same base. Because if they have the same base, what do I do with their exponents? Add them. Great. So this first one, I have a negative 3x that's being multiplied by that entire expression. And so I'm going to distribute that to every term in the expression. Now, I'm going to write it out, and I suggest at first that you do if you're getting them right consistently without writing it out. You still draw the arrows and write your terms, but I'm going to write out that I'm going to multiply negative 3x times the positive x cubed plus the negative 3x times the negative 4x plus, I should have 3 separate multiplication problems because there are 3 terms in that expression, negative 3x times 2. So now I can focus on just one piece of this at a time. There's only a 1 in there, right? That's really 1. Negative 3 times 1 is negative 3. What's x times x cubed? X to the 4th. Because there's this hidden 1 there, right? That's x to the 1st. Add the 1 and the 3 since we're multiplying. I now have 4 factors of x, 4 x's multiplied together. On this second term right here, I have a negative 3 times a negative 4, which is going to give me a positive 12. And I have an x to the 1st times x to the 1st, which is going to be x squared. And on my last multiplication problem, I have negative 3 times 2, which is negative 6. And I just have an x. There's no other x's to add exponents with because I'm not multiplying by any other x's. And this is my final expression for that product. Questions on that? Raise your hand if you've heard the term FOIL before. So you guys know how to use FOIL to cook with?
Yeah.
Ha ha ha. Well, a little story about FOIL. Oh, I thought we were there. We're not there yet. We'll talk about FOIL in a second. Sorry. Letter B. Letter B, what am I going to do? Distribute the 5x squared. So I've got 5x squared times x to the 4th plus 5x squared times negative 3x. You do not need to write this out if you can consistently get the answer right without doing that. But for some of you, this is going to help you focus on it one step at a time, at least while you're initially learning it. X squared times x to the 4th is x to the 6th. And here the 5 and negative 3 multiply to negative 15. You could drop the plus sign if you want. X squared times x is x cubed. So that letter B is done. Those of you who have heard the term FOIL before, FOIL stands for firsts, outside, inside, lasts. It's not going to do a ton of good. It'll help you for letter C, where we have 2 binomials. If we're doing the product of 2 binomials, FOIL is our friend. It helps us. But if we're not, I don't even need FOIL, and I can still do that problem the same way I would do it if it was 2 trinomials, or a binomial and a trinomial, or a monomial and a trinomial. I can't use FOIL here because it's not 2. There's no first on this, or last, or inside. And here, there's first and last, and that's the inside. It gets confusing. So you can use FOIL when you have binomials, but if you don't know FOIL, don't stress. I was absent when they taught FOIL, and every time my math teacher said, just FOIL it, I was like, what are they talking about? If there were people pulling out FOIL or something, I had no idea. But I did know how to distribute, so I always got the right answer. So for letter C, this is where the first come from, right? Here's x. I have 2 terms, and I'm distributing them into here. And so what I'm going to do, of course, the board's going to be complicated. What I'm going to do is take this x and distribute it to both of these terms. By the way, that is the same as doing firsts the x and the 2x, for those of you who like to FOIL, the outsides of these expressions are x and negative 5. So now that I've distributed the x, though, I also have to distribute this second term, the positive 3. That's going to give me 3 times 2x. Those are the inside terms in that, of those 4 expressions. And then 3 times negative 5. So if you liked FOIL and it worked for you, go ahead and do it when you have 2 binomials. But all you're really doing is taking that first expression and distributing it to the other parentheses, and then taking that second term and distributing it to those. And so what I've got here is 2x squared. This is negative 5x. That multiplies to positive 6x. And this multiplies to negative 15. But wait, there's more. What do I need to do still? Combine like terms. Those two are like terms. So this gives me 2x squared plus x minus 15. It becomes a trinomial. Quadratic. So you can do FOIL if you want, if it has 2, but really we're just distributing the first term into the other parenthesis, and then the second term into the other parenthesis, and combining like terms. In fact, that's what we're going to have to do on these next problems, including E and F. In letter D, we're going to distribute the 3x squared. We're going to distribute it to the 2x first. So I've got 3x squared times 2x. I don't like this. And then 3x squared times 3. And then negative 1 times 2x. And then negative 1 times 3. And can you look at that? You can look at that as FOIL if you want. It's not writing, but all I'm really, I can't write it on there, but all I'm really, oh, apparently I can. I'm distributing this first, and then I'm distributing the negative 1 to both of those. And so this one's going to give me 6x cubed plus 9x squared. This one will give me negative 2x, and negative 1 times 3 is negative 3. I think I'm going to have to switch over so you guys can actually see me work out letter E and F, because this isn't letting me write up there. We're going to do notes. All right, so we're down here at letter E and F, right? Before the U try. Is that right? Yeah. So I'm going to do those on this screen just because I can actually, oh crud, I'm going to do this. I'm going to make sure I have lots of room to write. And so you can actually see it. All right, for letter E, it's the same process, but this time I can't use FOIL. So I'm going to take this x and I'm going to distribute it to every term in the trinomial expression. That's going to give me x. What is x times x squared?
X cubed.
X cubed. What is x times 5x? 5x squared, yes. Remember, it's x to the first and x to the first. We're just adding the two exponents. And x times negative 2 is negative 2x. Now I'm going to distribute the negative 6 to every term. So negative 6 times x squared is negative 6x squared. You can write it next to all these. I'm going to line them up, the ones that are like terms, so I can just add them vertically. But you don't have to do it that way. Negative 6 times 5x is negative 30x. And negative 6 times negative 2 is positive 12. So this gives me a final answer of x cubed minus x squared minus 32x plus 12. Questions on letter E? On letter F, I'm going to follow the same process. I'm going to take this 2x and multiply it by every term, and you're welcome to write them out if you want to or feel you need to. 2x times 4x cubed. The 2 times 4 is 8. The x times x cubed is x to the 4th. 2x times negative x squared is negative 2x cubed. And 2x times 10 is positive 20x. And I'm going to put it here because I don't have an x squared term. But you don't have to do that. You could light them all up and then just combine like terms at the end. Let's try pink. That might not show. You guys might be able to see it. We'll do orange. Now I'm going to distribute the 1. The 1's the easiest number to distribute because I'm just going to take that other expression, write it out. I'm going to line mine up vertically. I've got a 4x cubed here. And here I actually have a negative x squared. And then here I have a positive 10. If you want, you could have these all listed out from left to right and then just combine the ones that are like terms. I do it this way so I can combine vertically. This gives me the resultant expression of 8x to the 4th plus 2x cubed minus x squared plus 20x plus 10. Take a moment to try. There's a question, yes?
Why didn't you fill in?
I intentionally left this blank because the other one didn't give me an x squared. And I thought, well, I'm missing the x squared. It might turn up in the other expression. And it did. So that's why I left it blank. But you could just do it left to right and not leave it blank. But you would still get this. Take a moment to try letters A through F, and we'll go over those in just a minute. I'll come by if you need help. As you're working, you should be getting these answers. If you get all of these answers correct, then you can move on to working on the practice that goes along with section 2.3 of our algebra units. On that practice sheet, though, you need to skip number 4. We have not done simplifying square roots or working with radicals yet. So all of the problems under number 4, you will skip for now. We're going to learn that later this week before our 1.6 lesson. But 2.1 and 2.3 are what we needed for our 1.5 lesson of our first geometry unit. So if you get these answers on the screen, then you're welcome to start working on that. If not, ask me for help. Now I need my mouse to work. It's doing crazy things. I tried to record one day and it did this. It was insane. It was like it was possessed. That's all I need to do.
Justin Schmidt.